Okay, so last night a few of us got together and we brainstormed some ideas that we thought we might want to talk about towards the end of the conference. So, one of the questions that the historians asked us was it valuable for astronomers to hear the historian's point of view? Because we heard that some astronomers, I think we heard that Don Osterbrock might not have always liked the astronomer's point of view. I don't know. What do people say?
Historians.
I think it's very useful. I mean, I've been working on the Richard question for between 30 and 40 years. And I have found this extremely useful to know what the beginnings of some of the Richard work was. Of course, I've always acknowledged Festus Sniper. I've always known him from the beginning because I worked here at Lowell Observatory for 3 years as an astronomer. But I think there is no answer to these things, as we've heard several times. It takes a synthesis of many people and many ideas. The historians, I hope, are the ones who get it right. I don't think the scientists ever will.
Greg?
Yeah, I think this is valuable because all of us scientists are a lot more narrow-minded in real life than we pretend. And it's really useful. You mature as a scientist when you develop appreciation for the connectivity of ideas and the transmission of knowledge and collaborative enterprise that it takes to produce a result that's usually credited to a single individual. But when you know the history behind it, you actually feel less obscure as a scientist, and you feel like you're making a contribution. So these kinds of things are useful. It should be a little bit more wide scale, so more narrow-minded scientists get opened up a little bit.
Chris, you have a comment?
Yeah, no, I agree with Greg, and I definitely agree with this statement, and I think the research astronomers here really benefited from the whole discussion. A less maybe pejorative way of putting it in terms of the research scientist is that it's a very, to get a job in professional astronomy doing research, it's extremely competitive, it's hard, and people at the level of graduate students are expected to be world experts on something. That's essentially what you're told when you do a thesis. And so, the trend to narrowness in science, which isn't owned by astronomers and geneticists that have their own version of it and so on, is part of a culture, the culture of doing research in academia. It's very hard to draw back from it, and most students are not advised to make themselves familiar with a broader literature. They just have to ratchet themselves up to the frothy edge of frontier of knowledge as fast as they possibly can, carve out a problem as theirs alone, and be the best at that. And there's not a lot of rear view mirror involved in doing that, and there's not a lot of context, and so people make mistakes. Research scientists make mistakes out of ignorance of the literature, not just the sort of snubbing of a previous generation of pioneers. It can be more profound and worse than that. It can affect the progress of the field. So I think this is a very important corrective measure to have more scientists hearing historians and philosophers' points of views.
Fred?
Oh, just to add one thing to that, one of the most important things for us to do, I think, especially once we're sort of established, is we get to decide what problem to work on next. What do we actually do to optimize our scientific productivity, both in terms of grant dollars and everything else. And looking at the historical perspective of how history plays out, I think, informs what choices we should make. So that is actually another interesting aspect of this exercise.
Yeah, speaking as an amateur astronomer and a former professional geneticist, molecular biologist, I discovered in my career when I was a graduate student, my supervisor insisted that we do a massive literature review on everything that preceded. And we're talking Stone Age here, the 70s. And it was then possible to do that. Today, the half-life of a paper in molecular biology is about 3 years, because of the sheer number and the rapid advances. And so if you have a graduate student and you want that person to succeed, you're going to put them on a rapidly focused topic that will quickly yield results and papers so that they can then move on in their careers. That almost forces them to be narrow-minded. And I think there a historical perspective, like a thorough literature review, at least when you write that thesis, or conferences like this are very useful because it's so easy to think you've discovered something and only to learn that 5 years ago somebody else had already and you'd never cited them. So,
But that's presumably something that would really come out in a specialist conference, would it not, rather than this one here?
Possibly, but also I think, to give students today who think you go online and you find everything you need very quickly, to give them a historical sense that, you're sort of standing on the shoulder, not necessarily of giants, but a whole bunch of other people, will provide a continuity that I think as scientists they do need to be aware of. And perhaps this kind of meeting or something like it can be very helpful in that regard.
I think I disagree.
Oh, you're a great, you always disagree.
I've had a great time finding myself wondering, why is it that I'm interested in this in my 50s in the way I wasn't in my 20s? And the answer is, as a young scientist, it's maybe unhelpful to know too much about what's been done. There's a quote, I forget who it's due to, but young scientists not knowing what's possible, not knowing that certain things are impossible, get on and do them anyway. Right? So when you're getting into the subject, it's probably a good thing. Obviously, you've got to know literature to an extent of knowing what's out there. But otherwise, probably the less you know about how it got to be like that, the better. You should just get on, remake the subjects. Because that's what young people do. They throw away the past. They don't care.
Okay, so we should change
And
this
then
to old.
Yeah.
Greater than 40? I don't know. Is anybody
So-
here? There's a few
So I
under
guess
40.
what
Ones under
concerns
40
me
close
is,
your-
what concerns me is the very fact that I'm here showing an interest in all this shows that my active years are behind me.
That's what it means, Joe.
Well, this seems to me, now that you put the clarification, the answer to me is very clear. The answer is yes. Do we have the opposite question somewhere?
Oh, we don't. Let's ask the
Oh,
opposite
yeah, the
question.
opposite question is what I'd like to know.
Historians.
Yeah,
what do you
we
think?
had about an even spread here, maybe not an even spread, but maybe a third or so of the talks I would characterize as essentially science talks. And did the historians benefit from listening to them? Did they know everything? I don't think they did. I didn't. David, you?
Yeah, certainly I was lost in a lot of it, but there's a certain flow, there's a certain type of communication, and I'm a historian who's very interested in the contemporary scene. If I were not interested in the contemporary scene, that might be more difficult. In other words, if I was a Newtonian scholar, I wouldn't be here. So you have to understand, I mean, when you talk about historians of science, in this case, you're talking to a few specialists of historians of 20th century astronomy. So in that case, yeah, it's very valuable for me to hear how you argue various points, to hear what's important to you, and as we go on with these questions, we can be more particular, but yes, it's important to me.
Just to follow up on David's point, is that it's very useful for us to watch scientists talk about things.
That's it.
Because we hear what's important and what's not, and what's valuable and what's not. And that helps us understand what's going on inside their heads, which is really what it comes down to. What we do is trying to figure out what's going on.
Yeah, it gives me a personal association.
This is kind of a back comment. I don't entirely agree with your old there, although I am. But young people, I have seen many young people who said, this sounds interesting, but then they are suppressed. They're told, okay, that's not the way to go. I think there is a lot of interest in young people, but there's also a lot of politics. And so I don't entirely agree with the limiting it to the old. I think many of our new ideas come from young people, and they should not be suppressed.
Yeah, can I just follow up on David's point? Certainly when the astronomers were looking at the historical issues, I found...
Can you speak up for the old people?
I found when the astronomers who are looking at the historical issues. For example, I found particularly interesting John's paper and Ned's paper looking at VM Slifer from different perspectives. I thought that was very valuable. And you know, if I'd have heard those before I'd given my own talk, I'd have come up with a slightly different talk, I think, and trying to put emphasis, and I think I would have had a sharper account in various sections of it. So I thought that was an extremely valuable thing for me as a historian to hear.
Any other historians want to?
Well, I'm not a historian, but I was going to say that I think it is valuable. When I was studying physics as a young student, many questions I had about the material, conservation of charge or whatever it was, how did people come up with this? This seems so strange. When later, when I read original papers, I found out, oh, they had the same questions. I think presenting a more historically accurate picture of the development of, say, electricity and magnetism when you're teaching the students can help them learn the subject better. I know I learned best in the historical context when I was studying a lot of these subjects.
How about a younger person over here?
As someone that's at the very beginning of astronomy, I think this the historical context, sure, it doesn't help me learn how to use the metric in any different way, but it does help me understand and actually learn it for the first time, and actually have it stick in my head other than from a class or something like that. So in that sense, I really appreciated everything I learned here. You know, I took notes that are going to help me with my class. So that's
Ari?
I believe that the answer to this question should be pointed, means to give concrete fact which I learned or someone else learned from this meeting. And just 5 minutes ago, John Peacock said that he appreciated my lecture because I explained that Friedman was the first who describes as hyperbolic negative curvature universe.
Well, not just the first, the only.
And the only.
That wasn't independently rediscovered until...
Right, and this in fact, this like took out forgot the biblical expression from the eyes of other scientists. I do believe that idea of flat universe would not come in mind for 10, 20, 30 years more, unless only because Friedman made it a negative curvature, and flat curvature, flat universe would be also possible in the eyes of Einstein and de Sitter. So this fact, just particular fact which astronomer could learn from a historian, and now my own experience, which fact I learned, and I believe is explained to me much. Again, I'm a bit concerned that people talking about priorities, they concentrate just on this small passage in Lemaitre, which was deleted in his English translation 1931. And this became like a pivot point right now of all the discussions about priority, which is absolutely misplaced in my opinion. But I got an idea why Lemaitre deleted it after I heard someone talk with a couple data for which obtained by Humazon. These 2 points which were below beyond 20 megaparsec, 20 and 30, and I think Lemaitre, who saw these 2 new points, which in fact made, for those who know what is regression analysis, understands that 2 outliers will make immediately a straight line just because they are over there. And what Lemaitre had is a small piece of data in the corner. So he realized that these 2 points are much more important than all his arguments with, even with 41 galaxies, but cornered in, near the beginning of coordinates. So for me, this was an answer to the question which is hotly debated in this conference in particularly, and which again I believe is absolutely inflated in significance. But the answer came from this particular talk of an astronomer.
Great. Greg?
Yeah, I just want to say that So conferences like this, so I like to teach history or philosophy of science from the point of view that ambiguous data supports all viewpoints. And sorting that process out is sort of, what this was about. I mean, who's going to get credit for discovering the universe based on a limited amount of redshifts and without a theoretical framework? I just find that introducing that to students and helping them think about it is the best way to instill principles of scientific literacy that I can think of. And so these kinds of things are very valuable. So, I have a nice module on the Shapley-Curtis debate. Now from everything I can put together a module on, galaxy redshifts, 1912, what do we do with them? And, let the students think about it. So, and these kinds of things really inform someone like me.
And just on your question, I mean, this has been an extremely valuable conference, I think, for a lot of people. But I would say I would worry about, we have two communities apparently. One is astronomers on the left-hand side, and then on the right-hand side we have the historians. And I worry about that for two reasons. First of all, as was pointed out earlier, I think it's an enormous benefit for any scientist to know the history of their subject, at least the basics. It really helps them, I think, in their careers and just in their whole approach to that's the real philosophy of science, I think, is to understand how things were found out. But the second thing is, it really struck me this weekend that, historians of astronomy are obviously you're quite a special breed. Because first of all, you all know a lot about astronomy. That's not a given, it really isn't. I think as historians of astronomy, you're all, you know this field backwards, so that's how you can do what you do. But, I can't speak for the States because I'm not from here, but some of you may know there's a new generation now in the history of science where that history has actually been written by people who are absolutely trained, well-trained historians, but they're not scientists. In fact, they have no training at all in science. And that happens quite a lot. And I think that's creating its own problems because while they do bring something to the table, to use that awful expression, they often have a rather peculiar viewpoint, I think, and that's because they simply can't quite understand, for example, the primary sources. They go to read a paper and they can't understand the paper. And if you think, for example, of the analysis John Peake presented, now that's a slightly different case because I know there's lots of astronomers here and historians here who could do that. But what I mean is that kind of specialized thing, or somebody, how could you write a book on the history of gauge symmetry if you're not actually that level of a theoretician? So I think the split that we've kind of seen happen over the years between the discipline of a historian versus the discipline of a practitioner, be it an astronomer or a scientist, I think if anything, I disagree with John. I think we should be undoing that split actually rather than allowing it to widen.
Good. We have some disagreement. Yes, ma'am.
Yeah, I have kind of follow-up to that, because I started my undergrad in astronomy and moved into history now, so that's why I enjoy things like this. Because I always use examples. If you're studying Russian history, it helps if you know Russian. If you're studying history of science, it helps if you know science. So it helps me, it's like maintaining a language that I know. I continuously talking to astronomers, can really maintain that. And then on a different level, when I look at, multi-split technology, I'm like, hey, that'll be what I'll write about in 40 years. So it's just kind of helping on both sides. Like, just good for me.
So I wanted to basically make a complaint about historians of science, partially borne out by this conference, and mostly not. Astronomy, of course, is a very popular subject among college students. I mean, a third or so of college students at my university take astronomy at some point. It's very popular. And one of the things that I find vital to make the class come alive is to tell stories. It's not the only way to teach it, but I find it's a big asset to me. Even though I have a reasonable pedigree in history of science. I studied with Owen as an undergraduate, and Gerald Holton. Nevertheless, when I talk about the scientific revolution, for example, my stories are basically those of Bertolt Brecht and Arthur Koestler. The first one is outright fiction, and the second one is considered by many historians of science to be pretty close to fiction as well. But one of the things that I know that, I feel bad about this, but year after year I keep doing it because the stories are good. Now, historians of science are generally pretty good writers, but they generally don't write things for the public. I would eat them up if they did. historians of science want to take that one?
No, you're absolutely right, and the reason is if when you write for the public, you don't get tenure for that.
Well, you already got tenure now.
That's right, so now I can write.
We'll be talking after this.
That's it, it's a question of professional credit. You get professional credit for publishing in obscure journals and writing books that nobody reads. It's unfortunate.
Okay.
I would echo that and say, looking around at the books that inspired me by the way they were written, flesh out the stories and the people, they were often by Timothy Ferris, trained as a journalist, and David Sobel. They were often not by historians of science. I agree with you. I would have liked to have the total expert's view on that story and that subject.
And of course, it's even worse when our source is actual astronomy texts who pay lip service to history, but as many historians of science have told me, it's absolutely true, when professional astronomers write on history, they're basically amateurs. There's a few exceptions to that. In fact, there are definitely some in this room. Outside of this room, there's not that many exceptions.
Should we move on to another?
That was a big one. That's a big one. They're not all that big.
Oh, David, yeah. I want to
Okay,
respond
David,
because Owen is here. I was looking for Owen up there, and you're here. One of the first books I wrote was a straight astronomy textbook, basically Introduction to Astronomy using a planetarium. And Owen was one of the ones who reviewed it, and he doesn't remember, which is safe. Now I can tell any story I want. But the fact was, I had come up with something which I admit was based upon my readings of George A. Bell's Exploration of the Universe for arguing for how Tycho searched for parallax and didn't find it. Owen wrote me and was quite puzzled and was wondering if I had discovered a new historical tidbit that nobody knew about, because that certainly wasn't, it actually made sense, but it was a post hoc astronomical rationalization of a historical event, which I never looked at the original literature or anything of at that time. This was a while ago. So that was a very important lesson to me. And I think Owen was the first to make me aware of the fact that there is a history of astronomy as presented by astronomers, and it tells you more about the astronomers themselves and how they view their history, which is fine, than it does about the history. But if you take the effort to want to know the history yourself, you have to go beyond the contemporary literature. Now, in answer to you, I was in the same boat. I mean, Bertolt Brecht and Kessler, I used those in courses when I used to teach astronomy. And we simply pointed out that this is how these historical eras, these very important events, entered the popular literature and how they're treated by it. And one way I found was that if there's anybody in the class who wanted to make the effort to read a little deeper and a little broader, it was up to them to do it, and they could get extra credit. Try that next time.
That'll be really successful.
Shall we try to move on? We have like a whole bunch of things. Why don't we try?
That was the biggest one by far,
yes,
though.
I think so. So these are things we've already discussed. So apportioning credit, we've already talked about that a bit. How we apportion credit for various things.
Well, this apportioning credit, it's not just who did it first and so on, but Hubble is probably a very typical example. Suddenly everything that was discovered was shuffled on him. He discovered about everything. And then of course politics come in as well. And when we do history of science, we actually want to understand how things evolved, how those before us, how they worked, how did they deal with their problems. And then you made the point, of course, well, also others made the point, it wasn't just Lemaitre on his own who did everything. And of course certainly not Hubble who did everything. So apportioning is not just a matter that the right person gets the right credit, but to understand how different people did different, made different contributions, and how this became a new picture of the world. So I wouldn't underrate that nor overrate it.
As I recall it, this item got written down on the list because I've argued that actually what we're trying to do here is to some extent an anti-historical exercise. So professional astronomers, professionals in any field, I guess, once they get old enough, they spend half their lives writing or reading letters of recommendation. You're forever saying X is really good, they did this great piece of work, you should hire them, and so on. And so from my point of view, it's almost a question of belatedly doing what should have been done for Slifer at the time. And these kind of just so stories that you find in history are as much of a myth as the ones we make up in the profession day to day, probably. I think it's the same phenomenon. That to make sense of the world, you've got to hang an exaggerated account of somebody's achievements around their neck, otherwise they won't get anywhere.
That's one point of view. This first.
To follow on, I suppose this is a question I have to historians of science, because I think this is probably something that most, one of the most important things historians of science do, which is not simply figuring out who did what first, like Friedman published his paper in 1922, but how do you measure influence? For example, you want to know to what extent, if any, Friedman's papers influenced people at this time thinking about the expanding universe. Sometimes it's pretty clear because you look at citations and look at people and you can say, oh yeah, clearly this is. But other times it's not so clear. So I'm just curious how historians go about doing that.
Go ahead, Ari. It's yours.
Yeah, fortunately, I am next, right, in line, and I can. I want to answer your question, right? It seems to me here is disagreement. It's about the nature of consensus between me and Harry. Harry is saying that Friedman was out of the debate 20s and 30s, which allegedly shaped the view how to discuss and what is proven and what is not yet and what should be more done. And I believe that 20s and 30s is decisive for this acceptance of expansion. And I don't believe so. I do believe that Lemaitre and Hubble, those people who decided to be in a final race by modern historians, they're guilty of misleading, in fact, many of them, many people who played that game, because underestimating age of universe brought to stalemate. It was a stalemate. Einstein was despair to find the truth, because from Hubble's and Lemaitre's computations it came 1.7 billion years, and Earth was already established as to be 4 or 5 billion years old. So it was absolutely non-clear from where a problem comes, and Einstein even stopped to think about cosmology. He just humbly insisted that his theory is correct, and parameters might be discussed further in the same book which I mentioned, in this appendix on cosmological problem. So I do believe that 20s and 30s not only didn't add anything to the whole debate, but just threw people back. And Friedman was rediscovered somewhere in the 60s when Soviet major physicists raised their voice. Kapitsa, Zeldovich, Fox said to some extent about that. But they constantly and repeatedly said that. They, for example, Kapitsa said Dirac didn't believe in positron. Because some people said, quoting Fock, they said that Friedman didn't believe in expanding. He just said, okay, this is mathematical model, and let physicists treat it further. And because of that, allegedly, Friedman didn't believe in his own theory. Because of that, he should not be given all credit. And Kapitsa said that it's nonsense. Dirac didn't believe in positron, and Kapitsa knows this personally. This is, I just quote what he wrote. And no one denies Dirac to be discoverer of positron. This is one point.
Okay,
but
let's try to stay focused.
Yeah,
Continue.
I do believe that Nobel Prize people just started from the point where Friedman left.
Okay, that's what
all
you, that's
20s and 30s were irrelevant for.
Okay,
they brought new theories, as you know, the steady state theory, other stuff. Lemaitre had to. It's clear why he was embarrassed to be to hear the talk by the Pope, because he was in a peculiar situation when cosmology was in inner contradiction. He didn't know how to get around that. He was embarrassed that Pope refers to this theory as established, while he didn't believe himself that everything was resolved there.
Yeah, Chris?
Yeah, my opinion is that I think apportioning credit is just a strange post hoc way of declaring winners and losers. May make us feel good, but what's more interesting to me out of this meeting is just to see how early in any subject, or maybe at any point in any subject, what really matters is what the network of people is. That many of these were point-to-point relationships or very small groups before the age of instant communication. So the whole idea of consensus and how that was achieved when people were either solitons sometimes or working in very incomplete dialogue between the other major thinkers was important. And then the other thing that is pointed out very clearly, and John had some of this in his talk, was how, to us, again, with that wonderful post hoc hindsight, the evidence is staring you in the face. And so what is the toolkit you need as a scientist in the moment with what you have available to you, your culture, your collaboration, your connections, that lets you see something or not see something, or take a bold step or not take a bold step? What's the group thing involved? Because although it's a different age 100 years ago, you could flash forward to now where the physics community goes through paroxysms about string theory and whether an entire generation has been lost to something that is undemonstratable empirically. And astronomers are, of course, locked into a paradigm they like an awful lot, where the two major components of the universe are extremely elusive. So these are uncomfortable, but now it's multi-billion-dollar enterprise. It's not a dozen or 2 dozen people who don't always talk to each other. That's pretty interesting. Maybe the same thing is going on, just scaled up.
Here. Good point.
Can I just follow up the general question about influence? Because I think one of the key things for the historians would be not just relying on the published materials, but to try and get at the issue that was raised about networks, to understand how information is flowing in letters, how there are informal contacts, who is listened, who is taken seriously. All those kinds of things can often be gotten from the archives in a way that you just can't get at them from the published papers. So often the historians are off grinding out information out of the archives, I think. And part of the reason is exactly that you just can't, the scientific papers tend to be the tip of the iceberg for certain kinds of issues.
We got about a half hour more, I think. Really? Yeah, really. So we have some other questions here, so let's move on. Let's get through a few things, otherwise I know everyone wants to thrash everything out to the very end, but we'll never solve every problem. How about this? Can astronomers handle nuance in their founding myths and future discoveries?
I don't even know what nuance is.
Thank you, Greg. We didn't think so.
It's a French word. Well, it's like, how many people can you assign a discovery to?
Nobel Prize.
How many names can you put on the space telescope?
Three people.
We call it the Schleifer, De Sitter, Friedman, Hubble.
Yeah.
More than that, we probably don't even care about. I guess it should be better. I don't care about nuance. I should, but I don't.
You might not, but nuance, I mean, the question is.
cares about you.
Oh, well, I'd rather hear what other people have to say.
Well, I mean, I think that this is the same thing. Can any field, can anyone handle this nuance? And I think we know that it's difficult for every field to handle it, because you got to teach people what the past was, and it's much easier. I think, as I said in my talk, these linear histories are so effective. People just don't want to spend the energy to teach the full picture, right? It takes too long.
If you give Nobel Prizes, you don't have nuance, because you can only give it to 3 people, right?
Yeah,
That's a major problem.
That's right.
Well,
Unless
the
you're United
AAS
Nations.
prizes are similar.
What's that?
The AAS prizes are, I mean, there's at least one prize that you can only give to one person or a couple of people, even if there's a whole team involved. You cannot give it to them.
Just on that, first of all, this thing of founding myths, for me, let's not overdo it. My response to Robert, and Harry says the same in his introduction, yes, of course the papers don't tell the whole story, but they're a hell of a good start. I mean, I think we should never lose sight of the fact that ever since the Royal Society was formed, science has this wonderful literature where when people think they've established something, they actually do write it down and it's tightly controlled, etc. It's an awful lot of fields of human activity that don't have that at all. And just for once, because we were supposed to be, what's the word, try and be a little bit controversial, I'm going to put it to all of you. If you think of the original Hubble graph, the original one that we've been debating, I think science is linear. I think it's linear exactly like that graph. Not every point lies on the line, of course it doesn't, it's all over the place. But it still does reasonably progress from one thing to another. And I think, now I'm going to get in trouble for saying this, but again, well, first of all, the historians of astronomy are different. As you just said yourself, you taught history. You taught astronomy. Well, that's a completely different thing. I know historians of science who have never sat a class in science. Now, I'm not talking about the United States, maybe it's different here.
Yeah, we're not a monolithic group.
Oh, yeah, no, okay. Okay. But by the way, can I just ask, is there any historian of science here who really has actually never looked through a telescope, for example?
Once.
Yesterday.
What I'm saying is,
the same order.
I wonder, I just get the feeling all the time there's this kind of inward knocking of science all the time. And I don't think it's as random as all that at all. I think it is reasonably linear. And I think what gets confused with the whole thing is professional historians don't talk to the public much. An awful lot of scientists, we have to do that. And just to add to the mix, here's what I'm interested in. I'm not so interested in about the whole consensus of science about who discovered what. I'm far more interested in things the next step, and we haven't talked about that, so I hope you have something on it, is when something's agreed in the scientific community, it doesn't always get into society. Sometimes it does and sometimes it doesn't. And that's a very big question, especially when something serious like global warming comes along. And that's really what I was hoping to hear a little bit about. But anyway.
We got to be careful which Pandora's boxes we open.
Yeah. I know theoretical astronomers who've never looked through a telescope. So don't come down on this story.
But again, I think that you need to be able to.
Can't hear you.
You need to convey those nuances to the public, just as Greg was saying, that you have to be able to convey those nuances to the public because that's the only way they're going to understand how science really works. When people come up to me and they say, "What did you discover today?" I just go blank. I've never discovered anything.
I discovered my monitor wouldn't turn on.
It's just much more complicated than that. We need to convey that complexity.
Well, we do. I'm surprised that nuance is being interpreted by half the people in the room as credit. I just thought it was more complexity.
Yeah, I agree.
Well, astronomers can definitely handle complexity.
Yeah.
Can they handle
read astronomical papers.
And they're founding myths. That's
Yeah.
Why is
okay.
that such an issue about Slipher, about Friedman? Because there is, we heard it throughout the meeting today, both sides of the question. Almost everyone recognizes that the history is complex, and yet you still argue over this astronomer doesn't get a proper credit, that doesn't get a proper credit, and none of us have the time, the wherewithal, or the presence of mind to simply say, well, there is you know, if there is a master narrative, let's collectively decide what it is, and it's not simple. That's, I mean, because we're faced with, as Deidre says, you know, what did you discover today?
Fred, you had your hand up for a
No,
moment.
I'd like to go back to that point, because I think it's really important that we communicate to not the people in this room, but to the people of the whole country, how the scientific method works. Because one, there's a lot of noise from the social construct folk about the scientific method varies whether a man does it or a woman does it, and a lot of kind of nonsense like that. And we need to educate them. There are scholarly articles about that. And I don't think that's serving us well, but also more to the point, we need to educate the public so that there is continued public funding for science and education. I don't know if you guys remember, but about 20 years ago, some of the people at NSF decided, we only want to fund results-oriented science. We only want to fund the science that's going to work. And what people don't understand is that you need this whole scientific community to be working, and then one guy is going to be the lucky one who wins the Nobel Prize or gets credit for the discovery, but all of us have to be working so that one of us gets that next step forward. And this communication of how the scientific method works is very important, and I think that if that's what you mean by getting the nuance out to the public, I think that's very important.
It is. I mean, your point, I hate to say it, but you just raised a sociological issue. And that is, you know, where you get your money from, what do your patrons expect? And as that changes, science, the practice of science changes.
But the way the scientific method and scientific discoveries move forward doesn't. The universe is still the same way, no matter who's paying for it.
The universe may be the same way, but the techniques through it that you apply or are allowed to apply to find them out do change and are subject to technology, patronage, time, you know, the nature of your position, who's employing you. All of those social elements factor into how discoveries are made. And I know that gets close to Harry Collins, that close to, you know, that's about as close as I'll get to Harry Collins and people like that. But I do respect that there is important elements of that to consider. I mean, look at Leviathan in the Air Pump. That's Chapin and you hate the book because it tells you that over time, scientists, people who would be scientists, accept different forms of evidence as authority. Look at Galileo. Images as authority, images as evidence. That was a new idea. You don't understand modern science without knowing that. And in the case of Chapin and Schaffer, it is the authority that comes through an experiment. It's the recognition of that. That is a fundamental shift in how science is done. It is that you don't deal with rhetoric, you deal with evidence. And, you know, I can't think of anything more profound. Sorry.
Go ahead.
Yeah. I want to just make a quick observation. I agree with you and with you. There is a major sociological thing in modern science because it's to a large extent money driven, and that means competition for grants, competition to get papers published, review boards that may not like the paradigm you're trying to propose and get a paper out, etc. That is a science management problem that scientists have to deal with. On the other hand, if we do not, as Deidre said, communicate how science actually works to the public at large, we're going to lose an awful lot of the perspective that the public has. And to be too nuanced there is a two-edged sword.
Yeah.
If we say the Hubble Space Telescope is named after Hubble because he discovered the expansion of the universe, people go, oh, great, he was a great man. But if we say, well, actually he, you know, maybe he cheated a little, and maybe there should be 5 or 6 others, and it should be the blah, 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 blah Space Telescope, they're going to lose interest, and they're going to say, you guys are all a bunch of crooks. So, you know, it's a subtle difference that in terms of how you sell science to the public, and then how we conduct science among scientists.
That's the nuance.
Good point.
That's really
Public demands heroes.
Joe.
Where does the public get its information about science? The same place college students do, Wikipedia. And I have in front of me the entry on Edwin Powell Hubble. Has anyone looked at that lately?
Hey, let's edit it.
That's right. You should.
Sure. Or you can just read it. Here, let me give you a microphone, Joe, because you're hard to hear.
You want me to read it?
Read the part that's got to be pretty quick.
Edwin Powell Hubble was an American astronomer who played a crucial role in establishing the field of extragalactic astronomy and is generally regarded as one of the most important observational cosmologists of the 20th century. Hubble is generally mistakenly known for Lemaitre's law, or Hubble's law, which was discovered by Georges Lemaitre. He is also mistakenly credited with the discovery of the existence of galaxies other than the Milky Way, and his galactic redshift discovery, with the loss in frequency, the redshift, observed in the spectra of light from other galaxies, increased in proportion to a particular galaxy's distance from Earth. This relationship became known as Lemaitre's law, or Hubble's law. These feelings fundamentally changed the scientific view of the universe. The existence of other galaxies and redshift was actually first discovered by the American astronomer Vesto Slipher. Using the data collected by Vesto Slipher and his, Hubble's assistant Milton Humason, a former mule driver and janitor, Hubble and Humason found a direct relationship between a galaxy's distance and its relative speed away from the solar system. Hubble supported the Doppler shift interpretation of the observed redshift that had been proposed earlier by Vesto Slipher, and that led to the theory of the metric expansion of space. He tended to believe the frequency of any beam of light could, by some so far unknown means, be diminished ever stronger the longer the beam travels through space.
So, Joe, the important question is, what are the sources they're citing for all of that?
I have no idea.
Possession is 9/10 of the law.
All of that stuff should have footnotes at the bottom.
There are footnotes here.
No.
Reputable footnotes to reference these references.
It's always unclear who wrote.
Joe, should we move on to some?
Yeah, we should.
Larry's got a point here.
Well, I just want to comment on this statement. What is the public going to feel when they learn that Hubble wasn't so honest? I think the public does know, and I think the public is sort of, they read Wikipedia, if they want to be informed, they know. And I think the mistake is on the part of the astronomers who don't have the courage to step forward and change the name and to or use the proper name in the first place. It's a political decision within the astronomy community as to who to name these things for, and it's done on the basis of money and influence and who is at the best observatories and so on. And I don't think the public is so ignorant.
They cared about Pluto.
Yeah.
Really, they
Yeah,
cared.
that's right. And did they care about Pluto because they knew anything about outer solar system objects? Of course not. They cared about it because they learned it in second grade.
That's
and
right.
things they learned in second grade must
Because
be
of
true.
Disney's dog. No.
Yeah, okay, let's move on to something else, because we don't have that much more time, about 15 minutes. Joe, 10 is one wants to go up and have some dinner and take off. So let's get to the heart of the matter, yeah? What, if anything, was missing from the historical papers or from this conference? I mean, tell us what you think. What, if we do this again in the future, what could we improve? Should we kick some people out or let more people in, or what do you think? Let's start with John.
Well, one thing that wasn't quite missing, but almost got missed, was it was just squeezed in right at the end in your talk, which is a fantastic point, which is this, what did you call it, the inevitable hero?
Yes.
We spent this all the time here talking about who was greatest, and I think that point, that all of this would have happened anyway, whether Slipher had been born at about the right time, is something we should bear in mind, and I'm surprised more people didn't emphasize it. And coming back to where we were before, if you're informing the public, this whole idea of heroes should be done away with. There's lots of smart people out there. Ideas have their time of ripeness, and almost inevitably they happen.
I think I'm going to be a winner of Stiegler's law of economy. Greg.
What I found annoying about, not this concept about, but Slipher's papers is he doesn't ever discuss how he chose his sample. and he doesn't ever list galaxies he looked at but never got a spectra of. So there's a huge selection effect. It's similar to making an HR diagram of the 20 brightest stars in the galaxy. Right? He did exactly the same thing. And that's sort of a major deal. And it's just, there's not enough details. I mean, you can celebrate his terse writing style, but you know, if I want to understand his statistics and his approach to this survey, this is what it is. It's a survey of galaxy redshifts. There's not enough information for me to calculate a selection effect and go, yeah, he could have got the right answer, you know, if he'd done it slightly differently. So that was, you know, that was.
Well, I mean, this goes back to this Lundmark 1924 paper I mentioned, where he does look at everything, and he doesn't find anything, and he tells you.
Oh, he looks at everything that has a redshift.
Everything they could get, all the data he could get his hands on. Yeah. Well, he was banned from Mount Wilson by that point. But, yes?
We should have invited Slifer, of course. But then I got to thinking, where is he? Where is he? Yeah.
Can you say a little bit more about what you mean by that? Can you say a little bit more?
Where is he buried? In Flagstaff? Is he here?
Yeah,
in
I think he's right here.
Yeah.
I think that's what it said.
So what, we should go to a seance? Is that
According to
what-
Wikipedia, he's buried in Citizen Cemetery, Flagstaff.
Citizen Cemetery in Flagstaff.
Okay, that's about 5 blocks.
Okay, more on, Joe had his hand up quite early. Joe, what do you think?
What was missing in this conference was a scholar of Hubble, someone who is familiar with Hubble's work.
We talked about that. Yeah, yeah, that was an unfortunate. We definitely have a scholar of Friedman, that is very clear. We have scholars of the math here, but we don't have a scholar of Hubble. That's unfortunate, I agree.
I'm not sure there is one. Frankly. I mean, a lot of people have looked at Hubble. Right? I think that the number of people who've written papers on the astronomy event in Hubble, many of them are actually in the room. I don't know anybody. I mean, the late Norris Hetherington wrote a guided text to Hubble studies, for example. But I'm not sure I can think of anybody right now. Certainly a professional historian who is not in this room.
All right. Well, there aren't many of us.
That's right. Other than Olga, I'm not sure who else.
Rare breed.
I don't think we can converge. I think we've come to that.
I mean, there is a popular writer, obviously, Marcia Bartusiak, in her account, because I spent quite a bit of time arguing with her on some of the things, because she sides, in my view, with Hubble too much, for example. But she's writing, obviously, a different sort of.
We tried to get her to come, by the way.
Oh,
Joe tried.
Oh, Marcia.
Yeah.
Oh, yeah, she was planning to come and something came up. That's too bad. That's too bad. About the convergence, I'd say we are talking. I feel a real commonality of, I mean, last night was great, you know. That was a very interesting exercise coming up with some of these themes and just listening to you guys talk among yourselves about the astronomy you do. I don't get to do that too often, and that was very valuable.
Ari, do you have a opposing opinion about this?
No, this reminded me, could we come to consensus? Means that your questions kind of converge also to a certain point perspective. So my answer is no, and why? Because there are, for example, there are experimentalists and theorists, as Cormac several times insisted on that. And for example, I read paper by Perlmutter, and for him, expanding is due to Hubble. And I believe all this would be due to Hubble. Maybe he will switch to Schleicher, or will share between them this honor, but never to deliver it to Lemaitre or Friedman, say, to theorists. And this is one plane of partition. And second plane of partition is geography. Because I see that this revolution, this what Joe read in public, this was written, I believe, just in last 1 or 2 years. Before, it would be written completely the opposite essay about Hubble. It's just a revolution which happened around Harris Nussbaumer's book, which made a revolution, in fact, in many minds. And why? And also important scholar Kra, Danish scholar. I see here European revolution against American predominance, say, in science. So Lemaitre put instead of Hubble on the first place. And as you observe, a scholar of Friedman is originally Russian as well. And the Russians, only Soviet physicists, constantly, continuously repeated that Friedman has a share in this matter, and they were not heard. Until 1960s, 70s, 80s, Friedman was just barred from the discussion. Later, he was given just equations, appeared two equations, didn't have name, or was given Friedman's name to these equations. It was like a lucky situation. But Friedman was out of the debate for a long time. So what I'm saying that there is geographical division is, it's appeared to be almost unsurmountable.
Geopolitical.
European scholars place forward Lemaitre, Russian scholars Friedman, and Americans think between Hubble and Slide.
No longer.
I don't know if it's so, I mean, I like the idea. I'm not sure that, I think there's more nuance than that. I think there are many people here who do celebrate Friedman and many people here who do celebrate Lemaitre. I'm American, I like Lemaitre, what he said. And those papers of Friedman, when they were translated into English, I was very good because my German is terrible, and they were great to read. And I think he deserves all the credit that he should deserve, absolutely. So I don't think it's so monolithic. I mean, I know it's hard. You're the only Friedman person here, so you have to fight everybody else to get your voice heard, but it's a fair argument, David.
Which brings up the question, when is enough credit enough?
Don't answer that. Let our artist answer that.
I have to say something as the artist here, and perhaps sitting in a parallel universe and one of right angles to everybody else. But I think there's some really interesting issues being raised here. The idea of convergence is an interesting one too. First of all, we have to define what you mean by that, because does that mean commonality of point of view? Or does it mean the opportunity to interact? And I think that's the more important part. And the opportunity to correct each other, or look at each other's practices and professions, and apply skepticism there is really important. The other thing I'd say is that you can't avoid the socio-political sort of context of science, and you can look at the hard science itself, but then everything that's happening is happening in this broader context. And one of the things we're talking about is this idea of a kind of critical reflexivity, and it's interesting to look on the computer and have an instant feedback. And I'd say that that notion of that context of critical reflexivity is not only expanding, it's accelerating. And you know, the rate of change and the rate of reflexivity will probably escalate. And that's probably a very healthy thing in some ways. Credit is a really interesting context. It doesn't matter whether you're in art or any area of activity. But you know, if you go and see a big film, and that's what a lot of it is now. If you think of the Hubble telescope or the Mars mission or whatever it is, it's a big movie. And when you get to the credits at the end, they're phenomenal. Most people have left the theatre at that point. But some people stay to the end.
Suggest we end with that, because then we will have begun and end with our artist, which I think is a great.
Yeah, it's 5:25. I think it's great. So.